This 3D simulation shows how a rotating coil produces an induced current when it spins inside a magnetic field. The red North Pole and blue South Pole create the magnetic field across the coil. As the coil turns, it cuts through the field lines, changing the magnetic flux through the coil. By Faraday's law, that changing flux induces an electromotive force, which drives current around the circuit. On the side panel, you can show or hide the magnetic field and current flow. You can also switch between conventional current and electron flow, which move in opposite directions. The collector ring control compares two important designs. Slip rings keep each coil end connected to the same terminal, producing alternating current, so the graph swings positive and negative. The split ring commutator reverses the coil connection every half turn, giving a rectified output that flows in one direction. The speed slider changes how fast the coil rotates, and the live data logger shows the current changing over time. You can pause, step through the rotation, and inspect the 3D model from any angle. Click the link in the YouTube description to try the simulator yourself.